Dear students, today we are going to start a new chapter, that is the first chapter of class 9, that is number system. Few concepts that we are going to study in this chapter. We are going to revise rational numbers, we are going to discuss about irrational numbers, we will learn about real numbers, we will see decimal expansions of real number, we will learn how to perform the basic mathematical operations, subtraction, addition, multiplication, division on rational numbers. We will learn a new method that is called as rationalization, and then again we are going to revise laws of exponents on real numbers. So let us see, first of all, let us revise that what are natural numbers. All of you are aware that natural numbers are also known as counting numbers. They are a part of real numbers, and it starts from 1, 2, 3 and goes to infinity, and they are denoted by a symbol as capital N. Let us see what are whole numbers. So when we add 0 to the set of natural numbers, we get another set that is called as whole numbers. So first set we have studied was natural number. Set is basically a collection. So first set we have seen was natural numbers denoted by n, and now we have seen that when we add 0 to the set of natural numbers, so it starts from now 0, 1, 2 and goes to infinity, is called as a set of whole numbers, and it is denoted by the capital letter W. Let us revise what are set of integers. All negative numbers, 0 and all positive numbers together form the set of integers. It is denoted by number Z. Revise what a rational number. A rational number is a number which can be represented in the form of p by q, where p and q are integer and q is always greater than 0, is called as a rational number, like minus 2 by 3, minus 2 by 6, 6 by 4 and so on. So carefully see the figure that I have attached here. So first we learned about natural numbers, and then when we added 0 it became a set of whole numbers. Then all negative numbers, 0 and positive numbers together form the set of integer. And now we have learned about rational numbers. And rational numbers already we have studied in class 8. See some more examples here. So the number is 5 and I have represented it as a fraction as 5 by 1. So it is a rational number. Yes, it is a rational number. Now let me see 1.75. When I convert it into fraction, it becomes 7 by 4. So it is also a rational number. Similarly, it goes for minus 0.1. It can be represented as minus 1 by 10. So it is also a rational number. But what about square root 2? The square root 2 cannot be represented as rational numbers. So what are such numbers called as? They are called as irrational numbers. I have shown you another example of an irrational number as pi. The value of pi is non-terminating, non-repeating. Okay, so if you keep on finding its value, it will not stop anywhere. So such numbers are called as irrational numbers. The numbers which are not rational are called as irrational numbers. So irrational numbers are also a part of real numbers which cannot be represented as the ratio of two integers. Now one of the common rational number I have explained you is pi. So the reason behind that is that it does not have a finite number of digits after the decimal. One more example I have here is root 2. So root 2 also, when you find out the square root, it comes out to be 1.414 and so on. So it is also having a infinite number of digits after the decimal. Some of the examples of irrational numbers are root 2, 3.14, root 3 and so on. Which are not rational are called irrational numbers, and together they form a set of real numbers. So I have shown you here rational numbers as well as irrational numbers. I would like to tell you a fact here. The ancient Greek mathematician Pythagoras, you are already aware about his name. We have learned about Pythagoras theorem also. He believed that all numbers were rational, but one of his students proved that you could not write the square root of 2 as a fraction, so it was irrational. And Pythagoras did not accept the existence of irrational numbers. Now we have discussed about rational number and irrational number, and together they form set of real numbers denoted by symbol R. So first we have studied about, let us see the figure clearly and let us start from the bottom of this figure. So we have studied about natural numbers denoted by N, and when we add 0 it becomes whole number denoted by W. Negative numbers and whole numbers together form the set of integers denoted by Z, or in simple form we can denote it by I also, but mathematically we denote it by Z. And when we have non-integer rational numbers and integers together, they form a set of rational numbers, and rational and irrational together form the set of real numbers that we have studied today. Representing the real numbers system, so natural numbers, whole numbers, integers, rational numbers, and then we have the real numbers combining rational numbers and irrational numbers. Now let us identify that a given number is rational or irrational with the help of decimal expansion. Few examples you can just by looking at them you can identify them as rational or irrational, like root 2, pi are irrational numbers, 1 by 2 is rational, minus 1 by 2 is also rational. But with the help of decimal expansion, we can also know that whether a number is rational or irrational. So there are three kinds of decimal expansions. One is terminating. Terminating means the decimal process stops. The remainder is 0. Or non-terminating repeating, which means the decimal process will not stop, but a particular number will repeat or a set of numbers will repeat. And the next one is non-terminating, non-repeating. That means neither the division process will stop nor it will repeat. So the first two kinds, that means the terminating and non-terminating repeating, are rational numbers, whereas non-terminating, non-repeating are irrational numbers. So I will again repeat. There are three kinds of decimal expansion: terminating, the process, the division process stops, and non-terminating repeating, that means one number or a set of number keeps on repeating, the decimal process is not stopped. And the third one, non-terminating, non-repeating, the decimal process will not stop and neither it will repeat. The first two kind, that means terminating and non-terminating repeating, are rational numbers, whereas non-terminating, non-repeating are irrational numbers. So if we see 7 by 16, so when we divide 7 by 16, the division process stops. The answer is 0.4375. So this process stops. So it will be a rational number. Two examples here, 5 by 11 and 7 by 6. I have shown you a division process also. So 5 by 11, if you see, the numbers 4545 are repeating, and this process will keep going on. It will not terminate. Similarly, 7 by 6, here the 6 digit is repeating. So these will be rational number, but the decimal expansion kind will be non-terminating but repeating. Okay, so in the first one 4545 is repeating, so we can write it as 0.45 bar also. Bar means 4 5 के ऊपर we can place a small line, which denotes that 4 5 is repeating. Similarly, in case of 7 by 6, we will put a bar on 6. That means 6 digit is repeating. We will not put the bar on 1. We will only put the bar on 6. Let us see the decimal expansion of irrational number, that is non-terminating, non-repeating. We have seen a process for root 2. So the answer is 1.4142, so on. It will keep on going. It will be non-terminating, non-recurring. So at every stage the remainder is different. So it is an irrational number. So decimal expansion of irrational number is non-terminating, non-repeating. I have shown you how to find a rational number between two given rational numbers 1 by 5 and 2 by 7. You have already done in class 8 also. You will convert, you can multiply this by the LCM of 5 and 7 also, and then convert the numerator and find the rational numbers between two given rational numbers. This I have revised here because in your first exercise, that will be your homework for today, you have questions of this kind. Guys, what we have done today, we have understood about the set of real numbers, that is a combination of rational numbers and irrational numbers. Rational numbers, a number which can be represented in the form of p by q, where p and q are integers and q is not equal to 0, are called as rational numbers, and numbers which cannot be represented as rational are called irrational numbers. We learned about decimal expansions of rational numbers and irrational numbers. So decimal expansion is of three types: terminating, like I have given you the example 2.5, 3.28, 9.81 and so on, and non-terminating but repeating, where a single number is repeating. One more thing here, when you are writing a non-terminating, repeating, non-terminating means you have to put small dots after the decimal expansion, which shows that it is non-terminating. Here also in the figure you can see that in terminating side there are only 2.5, 3.28 and so on, and in the other example the dots are given after the decimal expansion, which shows that they are non-terminating. Okay, and the third kind is non-terminating, non-repeating. So neither they will stop or they will follow a particular pattern. Here also dots are given to locate that they are non-terminating. So the first two, terminating and non-terminating repeating, are rational numbers, whereas the third one, non-terminating, non-repeating, are irrational numbers. Now the time for homework. So you have to do exercise 1.1 of your NCERT book, and I have given you few parts. You have to express the following rational numbers as decimal numbers. That means you have to find their decimal expansion, but when you find the decimal expansion, please write the kind of decimal expansion also, whether it is terminating or non-terminating, repeating.